Hello everybody, we're getting ready to do lesson 9.2, graphing ax squared plus bx plus c, part 1, part 2, part 3 available here. So we're going to graph ax squared plus bx plus c. Here is our standard for this lesson, part 1. We got a 38-point skill sheet and we got 0 points of note-taking. Okay, teachers, here is your bell work for today. We're going to match quadratic functions with their graph. Give your students 5 minutes to complete this. Okay, welcome back. We're going to match our function with our graphs. There's number 3, there's number 4, then there's number 5. Okay, so 9.2, graph y equals ax squared plus bx plus c. You graph simple quadratics, you will graph general quadratics. You can use the properties below to graph any quadratic function. You will justify the formula for the axis of symmetry in 38 in this lesson. So concepts like properties of the graph of a quadratic function is a parabola like this. This is a parabola, this is a quadratic. Opens up if a is greater than 0, so if a is positive, and opens down if a is negative. So there is your stipulation there. This opens up, so a would be positive here. And is narrower than the graph of y equals x squared if a is greater than 1. If it's greater than 1, absolute value greater than 1, then it is narrower. And wider if the absolute value of a is less than 1. It flattens out if a is less than 1. So the graph would flatten out like down like this if it was like 1/2 x squared or something like that. As an axis of symmetry of x equals negative b over 2a, here's our axis of symmetry, x equals negative b over 2a. That is our x coordinates of the vertex. Has a vertex with an x coordinate of negative b over 2a. So again, our x coordinate can be found where our negative b over 2a would be this coordinate right here. And has a y-intercept of c, so the point 0c is on the parabola. Right here is 0c, that would be your y-intercept. Okay, so onward into our first example here. Find axis of symmetry of this one here, of that quadratic. So for the function y equals negative 2x squared plus 12x minus 7, a is negative 2 and b is 12. Here's our a and there's our b. So the negative of b over 2a would be 12 over 2 times negative 2, which would equal 3. Substitute negative 2 for a and 12 for b, then simplify, and that's what we get. So now find the vertex of the graph of the function. Now that we know what our x value is for our vertex, we plug that back into our quadratic. So negative b over 2a is 3, and then we plug that back into our quadratic here, and we get 11. So our vertex will be when x equals 3, y equals 11. Vertex is 3, 11. Now, finding axis of symmetry and vertex, here's our quadratic here. We're going to do that here. Students, this is on you, so pay attention here so you can do yours. And let's get to our guided practice here. There's our quadratic. Axis of symmetry is negative b over 2a. So the negative of 8 over 2 times 2 would be 2. Be 8 over 4, would it not? Because the negative of negative 8 would be positive. So basically we have 8 over 2 times 2 is 4. So when x equals 2, y equals, and then we plug 2 back into our original quadratic to find our y coordinate for our vertex, and it's -2. So vertex is 2, -2. Here is our original plug in there into our graphing calculator. Then here is our the graph of this parabola here for this quadratic, and there is our min right there at 2, -2. 2, -. Okay, example 2, graph y equals ax squared plus bx plus c. So this time we're going to graph this here. Determine whether the parabola opens up or down. Because a is greater than 0, the parabola opens up. 3, here's our a. It's positive, so it opens up. And then draw the axis of symmetry, -b over 2a, so it's -6 over 6, which equals 1. So here's our axis of symmetry when x equals 1. Here is our axis of symmetry. And then find and plot the vertex, -b over 2a, and we found that out, didn't we? Or 1, to find a y coordinate, substitute 1 for x in the function. So we plug that in, we get -1. So when y equals 1, rather x equals 1, y equals -1, there would be our vertex there. So the vertex is 1, 1. And now plot 2 points. Let's send the x coordinate of the vertex and find the corresponding x values. So when x equals 0, y equals -1. Or better, when x equals 0, y equals 2. Right here, when x equals 0, y equals 2. And then when x equals -1, y equals 11. So we have this is our 11 up here. Here's our axis of symmetry here. Here's our y-intercept. And then this is another point here. Reflect the points plotted in step 4 in the axis of symmetry. So now we get to reflect this over here. And then this goes over here. We get a reflection here, a reflected point here. So when x equals 2, y would equal 1 in that case. And when x equals, let's see, -1, that'd be over here, so -1. So when x equals 3, y would equal 11 in that case. Draw a parabola through the points. That would be a general sketch for a parabola like that. So that would be it reflected in our axis of symmetry. Okay, find the axis of symmetry and the vertex of the graph of the function. Students, pay attention so you can do it here as well. Okay, 3x squared plus 12x minus 1. There is our quadratic. Axis of symmetry is -b over 2a, so the negative of b over 2a will be 12 over 2 times 3 will be -2, would be our x coordinate for our y coordinate of our for our vertex. So we plug in -2 here for x, and we get -13. So here is our vertex here. When x equals -2, y equals -13. That would be our vertex. So vertex -2, 13. Here's a sketch of it right here. And that was part 1 of 9.2, graphing ax squared plus bx plus c. If you want part 2, part 3, email me here. If you need worksheets or online tutoring, email me here.